For this one, so we are given a regular octagon in a circle of radius 2. So let's start with our circle. And our octagon. Let's say this is the point P, and this is angle phi that it makes with the nearest vertex of the octagon. So this distance will become so this distance becomes 2r sine phi by 2, and r here is 2, so it becomes 4 sine phi by 2. 4 sine phi by 2. And now moving clockwise, the angle from the next vertex becomes phi by 2 plus pi by 4. So the distance from that will be 4 sine phi plus pi by 4 by 2. So for all these 8 vertex, we'll have a multiple of 4, a multiplier of 4. So I'll simply write this 4 to the power of 8 times sine phi by 2, sine phi plus pi by 4 by 2, sine phi plus 2 pi by 4, that is pi by 2 by 2. So that's this vertex, this vertex, this vertex, this vertex, sine this vertex. Then the next would be sine plus pi plus pi by 4, sine and finally sine phi plus 7 pi by 4 by 2. Now we know that sine phi sine theta plus pi by 2 is cos theta. So this becomes cos phi. This becomes cos phi by 2. This becomes cos phi plus pi by 4 by 2. This becomes cos phi plus 3 pi by 2 by 2. And this becomes cos phi plus 3 pi by 4 by 2. Now we'll pair this with this and apply sine theta cos theta equals to sine 2 theta by 2. So That gives us 4 to the power of 8. Sine 5 by 2 cos 5 by 2 becomes sine 5 by 2. This and this gives us sine 5 plus pi by 4 by 2. This and this gives us sine and finally these two gives us sine 5 plus 3 pi by 4 by 2. So we get 4 to the power of 6 and the denominators go away. Now we'll use the identity sine theta plus pi by 2 again. So this is cos theta. So this becomes cos phi and this becomes cos phi plus pi by 4. Again this and this with this we'll get 4 to the power of 6 sine and again these two gets cancelled with a 4. Again this becomes cos 2 phi and so this finally becomes 2 to the power of 9 sine 4 phi. So the maximum will be, maximum for this is when sine 4 pi is 1, that is 4 pi is, or let's anyway, so the maximum is when sine 4 pi is 1. So the answer is 2 to the power of 9, which is 2. So I think this question should also be solved in the first go. It's straightforward and uses simple elementary identities. Yeah, so answer is 5 and 2.